Okay, so we'd like to welcome everyone to our second day of PasswordsCon. It's been going very well so far. It's nice to see the room so full as well. And as Dustin mentioned, remember to hydrate with something that's preferably got little to no alcohol in it. Just want to thank our sponsors, diamond sponsors, Adobe and Aikido, and then our gold sponsors, Formal and Dropzone AI. Then a reminder about cell phones. Just please put them on silent so that when Dustin's speaking, we don't have phones ringing or, worst case, Baby Shark playing as a ringtone or something like that.
Yep.
And then also, when it comes to taking photos, Dustin doesn't mind you taking photos of him or of his slides, but obviously adhering to the B-sides policy, not any photos of any of the attendees without their consent, both in this room or anywhere else. So we can get started. I'm trying to think. Sure, I think I know Dustin even more, almost 10 years now.
Yeah, sounds
10
right.
years now. And when it comes to cracking passwords, algorithms, working with Hashcat, working with anything to do with what PasswordsCon's about, I think Dustin's one of the most authoritative figures that we have. So you're going to learn a lot today, so pay a lot of attention. It's great that he's here to give us this talk. So without further ado, we're going to hand over to Evil Monk. Dustin.
All right, good morning, everybody. This talk was interesting. We'll get into the fun stuff here in my intro in a second. So, obviously, this is F5 load balancer service account decryption. Who here knows what an F5 is? Excellent, you're all in the right room then. So, who am I really? He already went through a bunch of it. You know, I collect black badges, Church of Wi-Fi. I'm a senior technical staff member. At one point, I used to be a network engineer, and that's the important part. I used to maintain, build, and manage F5s for a living for a bank. So that's where this magic comes all about. And obviously, if you want to find me on socials, I'm evil_mog on Twitter, evilmog on LinkedIn, and then mog.evil.af on Blue Sky. And yes, I had to go bribe some people to get an Afghanistan domain name. That was a whole different story. So, what is an F5? This is the important part. An F5 is a load balancer. So what does a load balancer do? It takes packets in, presents a virtual IP out to the world, and it dispatches things in the back end to alternate servers, anywhere from layer 4 all the way up to layer 7, and they can do funky mangling. So they can do similar stuff such as what's in Nginx. In fact, Nginx is now owned by F5, so it's kind of cool. The F5, the important part, will store credentials. Things like LDAP, for example, are stored in there. So say I need to go authenticate users talking to the F5 or talking to the application against Active Directory, I need to store a LDAP bind password. So who here remembers 2022 when all the F5s started getting popped? Who here had to work IR cases on that? Probably a few of you. So the question came up, if someone pops an F5 and has a full disk image or command line injection into an F5, what can they do with this? Well, the cool part about this is, actually, let me back in. Anyways, the cool part about this whole thing is you can actually get service account passwords out and do dirty things. But anyways, the important part, back to my little slide deck, because I go on a divergent rant. You can basically hide servers behind a virtual IP in a pool, and a lot of this functionality requires what's called local traffic manager, and then APM, whatever that stands for. It gives access to do advanced mangling. So, anyways, F5s are always installed in pairs. You have an active, you have a standby. And they need to be able to transfer their configurations between the two, including their encrypted data back and forth. This is why this attack even works in the first place. The F5s encrypt their stored service account passwords in their configuration file. It's like $M, $, 2-character salt, $, and then a bunch of base 64 characters, which I'll show in a second. Now F5s have a master key and a unit key. So the unit key, in the case of a physical device, is normally stored in the EEPROM. They don't persist it to the file system. In the case of a virtual device, they store it in the file system. This unit key encrypts the master key. I know it's weird. With AES 256 electronic codebook mode. And that's how you can retrieve the master key out. So the unit keys are unique to the F5s. The master keys are unique to the configuration pair. And you typically install them in pairs. And so then you use that master key to encrypt the configuration passwords. Now the secret that no F5 tech will tell you, but it is actually documented barely, is there's a command called F5MKU. This is designed for manipulating the master key files. This command is documented. The uppercase K flag is not documented except for one very tiny thing for synchronizing master keys between units when you're doing an HA recovery. If you go type the help command, as an example, on an F5 MKU, help, there is no dash uppercase K even mentioned in the command file. But if you type F5 MKU-K as an example, there's a base 64 configuration key. So this is how we can go do some very nefarious things. And by the I talked to F5 cert, they're like, hey, this is okay doing the talk. They're not really revealing anything public, or not public. We're just, you know, you're making people aware that if a service account password is it stored in an F5 and your F5 gets popped, please just rotate that service account password because it's been compromised. That's the whole gist of this talk. So anyways, the next part we're going on to, as you can see here on this command, and that's why I went to black and white on white, doesn't look that great. So for the password extraction, we use this really cool command. So in F5, it has two shells. You have bash and you have what's called TMSH, the traffic management shell. So from a bash shell, you can run TMSH commands. So F5s have these things called partitions. So I can store like a partition for one app, partition for another app, and make an F5 appear as multiple partitions. If you compromise one, you can tell it show me all of the commands for a partition, for example, or just give me that's what the recursive is on that show running configuration. It allows us to see everything in an F5, which is great for when you're doing a compromise assessment or running a red team. So what that looks like here, I'm going to make this easier for you guys to see. Oops, wrong one. Aha. So what we can do is we actually grep for service account passwords right from the command line. So we're doing TMSH, quiet, C, CD into the root directory, show the running config recursive, and then grep it for $M$. Looks something like this. So when you're looking at, there we go. Here is like an example of a bind DN and bind password. It's a $M$, a 2-character salt, and then base 64 encoded. Fairly easy and straightforward. Now, the cool part about this, the decryption is relatively simple. So, pardon my terrible color coding. I tried to do this because I don't like using pointers. So, you have your $M$, your salt, base 64 encoded. So you take the prefix. We're going to remove this later, but you store it in your script to go strip it out. You then base 64 decode that string at the end for the $M$. That gives you the raw bytes. Grab your the AES key using F5 MKU, and this is AES 128 electronic codebook. Every Python library speaks this. OpenSSL speaks it. So you base 64 decode your AES key, decrypt the cipher bytes of the AES key, remove QD from the decrypted password. That's it. That took me, a little bit to figure out, but it wasn't terrible. So the example. Now it's demo time. Let's see how great my demo skills are today. Python 3 f5.py. So we're going to grab the master key from this box, f5 mku-k. And where's my cursor? Oh, there we go. Found you. It's the only curse of doing light mode. So we're going to paste you. Oh, come on. Command V. Now we're going to grab the encrypted password. So in this case, let's grab... Oh, this is also handy because you can decrypt the keys used to go talk to F5 to go pull firmware updates and other status updates down as well, because every F5 gets their own. So if you want to do some research later, bonus research activity. Anyways, we'll go copy you. You're going to copy you. And... congratulations, EvilMog B-Sides LV 2025. Now, the other way you can do this... Thank you. Now, the other way we can do this, if I remember correctly, we can grab the unit key out using some entertainment. So here is the unit key. It's just stored in hex on the box. It's on the config big IP KStore unit key. We're going to copy you. Damn it. I can't type today. And there we go, copy. So I have another tool here, Python 3. One sec. I wrote this tool on the plane, so I apologize. We put our unit key down that I just copied out and the master key. and it will give you the output of the M5 MKU. I discovered this from another researcher that gave me some more details, but that is in a gist how this actually operates. And the good news is, here is your QR code that I swear is not phishing. It just goes to that URL. I promise I will not hack you. You're not paying me enough for this. And I will upload these slide decks to the repo for you so you can go through with your heart's content. If you want to play with this, you can get an F5 demo license. They give them up for about a month. You need to use your corporate email to go do the request. They do approve it. They just download the OVA and activate the LTM and go play with one just to go see how they operate. So you can recreate this to your heart's content and do some more research on what that magical other F5 key does. With that, questions?
It looks like, this recovers the password used for the cloud state. What about like in a FIPS enabled system? Does it, oh yeah. Sorry, just looking at the decryption there, it looks like you're getting the sync group password so you can get the configuration. I'm just wondering if it behaves the same in a FIPS enabled system.
I've never tested it in FIPS, to be honest. We don't do FIPS up in Canada, so in theory, and this is just me postulating, if they store the key in an EEPROM and they make it so you can't do like and you can't recover the key, it might not work. But the thing is, every F5 needs to synchronize with another pair. So if a FIPS-enabled F5 backup node dies or primary node dies and you swap it out, you have to get the config file moved over somehow. And that's the master password is this synchronization key between the two. So in theory, this should work if you get that master key. One of your techs will eventually have it, or yeah. But if someone wants to test on FIPS, let me know.
Yeah, sounds good. Thank you.
It's coming, it's coming.
You make him get his exercise.
I would throw it, but I don't want to buy them a new one.
Okay, so this problem of synchronous bind passwords isn't unique to F5s, right? You run into this in like SSSD.
Yeah.
Basically, anytime you're authoring to LDAP. A common mitigation we've seen for this is instead of using a bind password, just stick a certificate on the box and then run your LDAP server so that it uses MTLS to authenticate.
Right.
Does similar problems apply if you're using that mode? Does F5 even support that? Like other than a bind password? Any better?
F5 does support storing password or certificates. I don't know if the configuration allows you to do MTLS to a LDAP system. It also depends if the Active Directory let you do it, but the answer is that you can probably configure it that way, but then the private keys are all stored on the box anyways, so if they're popped, you still have the same problem.
Right. If your box gets popped, you're dead, right?
Right.
And
that's where this whole piece came from, was someone's like, our F5s should be fine, we don't need to cycle all our passwords. They were popped, but like they're encrypted, so don't worry about the codes. No, the one thing I want you to take away from this, if your box gets popped, everything that's on there, even if it's encrypted, is compromised. Please cycle.
Any other questions?
It doesn't even have to be with this. Life, the universe, anything, Hashcat, good sushi restaurants on the strip. Sake.
Okay. So the -K option was slightly documented someplace.
Yes.
What about doing digital forensics to try to dig it out of the binary if it was not documented?
You know, we didn't attempt to do that because we just knew the command was documented as like an F5 tech, because they have a whole policy on here's how you replace your box. So I didn't bother, but yeah, you could reverse this thing. All it is the Linux system under the hood.
Thanks.
Going.
And again, that font was the Atkinson hyper legible font. I swear I love it. I mean, what's everyone thought? Was it fairly readable? Cool. Thank you for being my UI testers.
Okay.
Awesome. Thank you all.
Thanks,
feel free
everyone.
to hit me up on the socials. In fact, there is my socials again if you want them all. Feel free. I don't bite. I happily answer questions on Discord, Hashcat, Life, Universe, everything, and Sake of all things.
Okay, before everyone disappears, how many users of Hashcat here? Okay, awesome. How many of you know Hashcat version 7's just been released?
Oh, dude,
Okay.
Hashcat 7 is amazing. There's so many little cool things that are now in it. Like, I'm very excited. First release in 2 years?
Yeah. I've got a bit of a summary from Jens from
Cool.
Atom. So over 900,000 lines of code have changed in Hashcat. This will, by the way, I'll put a QR code up now that you can just scan to get to the Hashcat wiki and see all of this. New features that are interesting: assimilation bridge, so you can now integrate external resources into Hashcat like FPGAs on the fly. There's a Python bridge. So if you want to write a custom algorithm or you want to support some changes to an algorithm on Hashcat, you can now do it in Python without having to rewrite any or recompile any code. Hash mode auto detection, okay, for those of us who struggle to identify what it is that we're working with.
Now, this doesn't work on things like NTLM, MD5, and anything else 32 hex, but it works on almost everything else.
Yeah, and then new hash modes, Argon 2, Lux 2, with full GPU acceleration. MetaMask, Microsoft Online accounts, GPG, OpenSSH, SNMP version 3, and 60 plus more that you're welcome to read about on the wiki. New compute API support, so it's no longer only for OpenCL and CUDA. You can now also use it on Apple Metal, optimized for the M1 and M2 chips, and AMD HIP, which is their GPU version of CUDA. And of course, improved performance across all the hash types. So I'll put the QR code up, but yeah, download Hashcat version 7. It's been a part of PasswordsCon since, I think, inception. There's been talk.
Thereabouts, yeah.
With
But this
Hashcat.
new version is really amazing with all the things, because you also like send out certain parts, different parts of a pipeline. It's great for automation of your entire workflow. I'm just so excited.
Yeah, cool. So download it, try it out. I'll put the code up now. And finally, once again, thanks very much to Dustin, to Evilmark for his talk today.